I was running this compressor the other day and I noticed that it was hesitating, and even though it was building full pressure, it would cycle high and low. So I figured there's something wrong mechanically, and it would either be the bearing at the of the bottom end or the piston itself. So I took it apart, and what I found out is, so this is the connecting rod and piston. It's not an assembly because it's actually a one piece. So there's no wrist pin here. Usually a piston will swivel, and here it's just all a single casting. The bearing went bad. All the grease came out. I cleaned it up a little bit at this point, but it really doesn't want to turn at all. So that was the reason for this hesitation. During operation, it was building full pressure because the two reeds, one of the reeds is in the piston, and you can see that's how the reed works. And there's another reed internally in the head, and I didn't feel like taking this whole thing apart. Well, there's a little piece of the gasket I should probably remove, but I can't pull this plate out. And then there's another reed in the head, and the way the entire system works is as the piston goes down, this reed opens and it traps the air between the piston and the head, and as the piston goes up, this reed closes and this reed opens, and it pressurizes the tank this way. And in order to generate the up and down motion of the piston, we have this electric motor, and the electric motor has a crank that I'm rotating right now. And so this crank can also be removed. There's a set screw here that can be removed through this hole, but there is no need to do that because you can rebuild the piston just by pressing the piston or the connecting rod of the shaft. Here's the bearing that I'm omitting, but the piston sits in this orientation. You can see that there's a counterweight here. So as the piston goes up, the counterweight is going to be down. And by the way, here's the reason why, if you have one of these compressors, you probably notice that in operation, when a compressor is on a smooth surface, it tends to kind of want to walk around a little bit. And so if you look over here, you can see a real crankshaft, and you can see that there are two flywheels on either side. And so here you can see that there's the flywheel, or a part of the flywheel, the counterweight, is only on one side. There's no second counterweight. So even though supposedly this assembly is balanced up and down, it's not going to be balanced laterally or with respect to this axis. So that's the reason why this thing vibrates. What I wanted to do is just talk about how to get this thing off the shaft. So first of all, there's a snap ring here, which was, by the way, installed incorrectly. And the correct way to install these snap rings is to make sure that the flat surface is against whatever flat surface that might be exerting a force. And in this particular case, it would be the bearing. And this thing was actually reversed, so the flat surface was facing out. But that's something that I'm going to have to remedy when I reassemble this. It's not a big deal. But the way I pulled the connecting rod off was with this puller. And so this is kind of a makeshift rig. This is really a slide hammer, and I didn't have a small puller for this purpose, so I had to modify what I had. And so I just basically removed the slide hammer part, and these things fit perfectly behind the base of the connecting rod like this. So all I needed is something to push against the shaft. And so this tool comes with this attachment. And so what I did was just use a cap screw that just fits through there. And then you toss a ball bearing on top of that. And you do that so that you can actually have contact between this end and the cap screw, because the cap screw is recessed. And then when you screw this on, you have a situation where you can actually push with this screw against the shaft. And as you screw the handle in, it'll press the bearing off the shaft. You can also use a nut here just to keep everything straight. It's not necessary, kind of an optional thing, but you can do that. So anyway, this is how you remove the piston from the crankshaft. The second thing you have to do is get the bearing out, and the way you do that is just with 2 sockets and a vise, and the sockets have to be sized so that the small socket has to be able to fit through this side, because you're pressing the bearing out from this side out. And you can see, by the way, that there are stake marks here that they use to retain the bearing. But anyhow, so you use this socket to press the bearing out, and you need another socket on this side, and essentially the vise is just going to squeeze these two together like that. And the key is that the bearing needs to be able to fit inside here. It's very simple to pull this thing, the motor, out of the from the top of the compressor. There's just 4 screws, and then there are 2 of these leads. You just need to keep in mind that these leads have locks on them, so if you just pull, they won't come off. So you have to look here and see that there's a little lock right here that you have to depress. And when you do that, this lead will come off easily from the corresponding, this is a female, corresponding male lead. And then this particular guy mates with this female lead. And here it's a little bit more difficult. You can see that there's a lock here. And what you need to do is you need to use a tiny screwdriver to essentially just lift this part up a little bit, just pry it up, and then you'll be able to pull it out, because otherwise it locks, the lock's very positive and you won't be able to pull it out if you don't do that. And then you just kind of push this thing back in and deform it back into place, and it'll lock next time. So these are the only 2 things that you have to worry about when you try to remove the motor. This is the bearing right here. I'll put the numbers in the description. This is a replacement bearing I purchased. It's $6. NSK is a Japanese brand, very good bearing.